algebraically, you're going to have to plug in f of negative x. So if it's even, if you plug in f of negative x, you need to have f of x. So that's when it's even. And if it's odd, you need to plug in f of negative x as well. But instead of having f of x, you need to have negative f of x. Does that make sense? And the reason for that is because if you're looking at an even function, so say for example, let's start with the basic. We have y is equal to x squared, which is a parabola. We know that this is an even function. So you're going to have this graph right here. So this is y is equal to x squared. And if you think about the symmetry, there we go. So this is an even function. So if you think about the symmetry, that means your function remains unchanged if it is reflected on the y-axis, right? So if you think about this y-axis as sort of like a mirror, so when you flip this part, right, it becomes the exact same reflection, right? So it's symmetry around the y-axis. But for an odd function, let's say you're looking at y is equal to x cubed, which is a cubic function. Okay. So your symmetry is actually 180 degrees, right, over here. And you have a point symmetry, to be specific, right here. So when you kind of rotate this, right, 180 degrees, so you're looking at from here, rotate that until here, right, 180 degrees, you're going to see that your function remains unchanged. So that's the difference between even and odd functions. And that's why you have this positive symbol right here versus the negative sign right here. Okay, so hopefully that was clear. But for this three questions, A, B, C, all you have to do is really evaluate whether you're going to have f of x as a result, which is the exact same thing as your function, versus if you can take out the negative sign and then you're going to have your function, f of x. Okay, and if it's neither, that means it's not going to be any of the two, right? So let's start off by plugging in f of negative x right here. Okay, so we do have 1 over negative x, and then you need to cube this, right? Plus 1. So if you think about cubing negative 1, right? Because this is a negative 1 coefficient, we can actually say that this is going to be 1 over negative 1 cubed. So we're taking out that cube, and then we're left with x, right? Plus 1. Does that make sense? So this should still be cube, right? Because we're still copying that cube because it's raised to 3, but then we're taking out the negative 1, and as a result, we know that any negative number raised to an odd exponent is always going to be negative, right? So therefore, we're going to have negative, right? So this negative 1, you can have that outside of x cubed. So you're going to have x cubed, and this is going to be plus 1. Okay, so if you think about this negative x cubed, right, this is not really outside of your function. It's actually just beside x cubed, right? Because if you have to take out the negative sign or factor out the negative sign, you're going to have negative, right, 1 over x cubed minus 1, right? Because the negative sign gets distributed if you have this right here, so you're going to get negative x cubed plus 1. So as a result, you're going to say that this function is neither. And why is it neither? Well, if you look at your function, right, your f of x originally is 1 over x cubed plus 1. And this negative sign right here, if it's odd, that means you're going to have this negative sign outside, but you need to exactly have the same function, which is f of x, right? But is it the same function? No, because you have a negative 1 here as opposed to plus 1. That's why it's neither. Okay, hopefully that makes sense. Moving on to part B. we have 2x raised to the power of 4 plus 3x squared. So when you plug in negative x, so same thing, raised to the power of 4 plus 3 times negative x squared, you're going to see that you have even exponents, right? So what's the rule when your coefficient is negative, right? Or any number really, when you raise it to an even exponent, right? It's always going to be positive. Okay, so as an example, if you type in -2, right? We know that, let's just keep it as -1, just so it's simple. Okay, so this is -1. If you raise this to an even exponent, let's say 4, right? Type this into your calculator, you're going to get 1, right? So that means anytime you have a coefficient or a number raised to an even exponent, it's always going to be a positive number. So in that case, you're going to get exactly 2x raised to the power of 4 plus 3x squared, right? And as you can see, 2x raised to the power of 4 plus 3x squared is exactly the same g of x, right? To begin with. So therefore, since we know that g of negative x is equal to g of x, we can say that our function is even. It's not too bad, right? All you really have to do is plug in your negative x. Okay, so moving on to h of x, which is 1 over x cubed plus x raised to the power of 5. So here's the thing, because you have raised to the power of 5, it gets a little bit tricky, but you're going to do the same thing for, so it's the exact same thing as the other two that we did. So you're going to plug negative x. So you're going to have h of negative x, and that's equal to 1 over negative x cubed, and this is going to be plus negative x raised to the power of 5. Okay, there we go. So as a result, right, remember what I said about if you have a negative coefficient, you're raising it to an odd exponent. Therefore, the number would remain negative, right? So that's what we're going to do. So we have 1 over, this is going to be negative x cubed, right? And then we have negative x. Okay, so from there, we can take out this negative symbol or negative sign, right? Such that this is now going to be negative, right? And by the way, because you have 5 here, we can say that this is -1 raised to the power of 5. Because remember, you're taking the -1 out from an exponent of 5. So you need to make sure you have that 5 there. And then you can rewrite this as 1 over x cubed plus x, right? Raised to the power of 5. Okay, so there we have it. And then now you can see that, again, I've probably said this so many times now, but if you have a coefficient that is a negative number and you're raising that to an odd exponent, that means it becomes negative, right? So you're going to have this -1 here because of this odd exponent, and then you're going to have 1 over x cubed plus x raised to the power of 5. So as you can see, you have a negative sign out here. When you plug in h of negative x, right? You're getting negative of h of x, which is an odd function, right? Because going back to this, what did we say? If it's an odd function, if you plug in negative x in your function, if you have a negative sign and if you're getting the same exact function, which is f of x, you're going to have an odd function. Cool. Again, as a reminder, all of my sessions are recorded, so you don't have to quickly jot everything down. Just take a seat, take your calculator out, plug in the values, calculate them with me, and just pay attention. So for number 2, it says graph the following functions. You have y is equal to -x times x minus 3 times x plus 4. Okay, so we're just going to do a recap with multiplicity and degree, and also the sign of your leading coefficient. So those are the three things you have to remember if you're graphing functions, and specifically they're polynomial functions, right? So this is a polynomial function. So first, let's identify three things as I mentioned. So if you're looking at this negative sign right here, that indicates that you have a negative leading coefficient, right? And you're probably wondering right now, what does the leading coefficient and its sign has to do with like drawing or graphing the function, right? So if it's a negative leading coefficient, so we're gonna have that right here. So leading coefficient. So if it's a negative leading coefficient, that means when you're graphing your function. So for example, if you're looking at a linear function, which is y is equal to x, say for example, versus y is equal to negative x. So we know that if you're graphing y is equal to x versus y is equal to negative x, if it's a linear function, that means your line is passing quadrant 3, right? Because this is quadrant 1, 2, 3, 4, versus something like y is equal to negative x, which is quadrant 2 and quadrant 4. Does that make sense? So the negative leading coefficient or the positive leading coefficient would determine whether your function is passing quadrant 1 and 3, if it's let's say y is equal to x, versus quadrant 2 and 4 when it's a negative leading coefficient. Same thing really applies for example, y is equal to x cubed, right? Which is what we know is an odd function, right? So we have something like this. So we know that it's quadrant 3 and quadrant 1 when it's positive, and if it's negative x cubed, we know that this is quadrant 2 and quadrant 4. And guess what? It's similar to y is equal to x squared, right? So let's just scroll down just to see and compare them. So y is equal to x squared. This is going to be on quadrant 2 and quadrant 1, right? And if you have y is equal to negative x squared, you're going to have that on quadrant 3 and quadrant 4. Does that make sense? So it matters where you're going to graph that. Okay, so I can erase this now. So that's for the sign of the leading coefficient. So let's move on to multiplicity versus degree. So you've probably heard what multiplicity is, and also zeros, right? Zeros and multiplicity are related to one another. So for example, you're looking at x, right? So first of all, you have x, you have x minus 3, and you have x plus 4, right? So your zeros are going to be 0, right? Because x is a 0. And you have positive 3 and negative 4. So maybe we can just group this based on the smallest versus the largest. So we have negative 4 to begin with because it's x plus 4 is equal to 0. Therefore, you're going to get negative 4, right? And then you have 0, comma 3, right? 0 for your x minus 3 is equal to 3, right? So in that case, you're going to see that the multiplicity of x plus 4 is going to be 1, right? So what is multiplicity? So multiplicity is when you're looking at different terms and then you call this sort of like an exponent. So if you look at x plus 4, your exponent right here is actually 1, right? So the multiplicity of negative 4 is actually 1. Multiplicity of x minus 3 is also 1, right? So let me erase this so you can see everything. So this is 1, right? This is multiplicity of 1, and this is also multiplicity of 1 because all of your exponents are actually 1. Does that make sense? Okay, so multiplicity is 1, 1, and 1, right? However, if you're looking at the degree of your function, that means the degree is your summation of all your multiplicities, right? It's going to be 3, right? Because 1 plus 1 plus 1 is 3, right? So the degree of your function is 3. Okay, so why does the degree matter? Well, the degree matters because at least you know which quadrant it passes through, right? Because if you're thinking about an odd function versus an even function, right? This is what I tell my students to really remember during the test. So if you're looking at, let's say, a negative leading coefficient if it's an even function. So say for example, you have negative x squared, right? You would have to, so this is the one that we talked about earlier, you would have to look at quadrant 3 and quadrant 4, right? So you know where your function is going to start and where it's going to finish. So it's going to start at quadrant 3 and then you're going to finish at quadrant 4. So that's the position of where you're going to draw. However, if you're looking at y is equal to negative x cubed, you know that it's not at quadrant 3 and quadrant 4 because it's actually at quadrant 2 and quadrant 4. Does that make sense? So when you draw this graph, you know that if it's degree 3, therefore it's an odd function, right? And if it's an odd function, you're supposed to expect that this is what the quadrants, or this is how your graph is sort of going to look like. So these are what you call like templates that I like to tell my students to remember during the test. So you have an idea of where you're going to start drawing the graph, because otherwise it's just going to be overwhelming. Okay, so now that we have that, we're going to have a number line, and then you're going to graph all of your, sorry, not graph all of your zeros, but plot them, right? So this is -4, 0, and 3. Okay, so we know that this is all of your zeros, and then first of all, because it's a negative leading coefficient, it's an odd function, you're supposed to start on top of your x-axis, right? This is your x-axis. And then because you know that the multiplicity of x plus 4 is 1, that means you're going to cross, right? Okay, so here's the thing. If you have an odd exponent or odd multiplicity, you cross. Okay, maybe we can just write that here. So odd multiplicity, that means anytime you have an odd number and it's multiplicity. So say for example, you're looking at 1, 3, 5, 7, right? All of your odd numbers, you're going to cross your x-axis. And if it's an even multiplicity, you're going to bounce, right? So you're only touching, you're not crossing. Okay, so let me just abbreviate that. So cross, and then you're going to bounce, right? So in that case, you're going to cross. You're starting from quadrant 2 because you know it's a leading coefficient of a negative sign. So you're crossing this, right? Again at 0, because its multiplicity is odd, you're going to cross this again, right? And then you're going to cross another one for 3, right? Okay, there we go. So this is how your function is supposed to look like. So you're just crossing, right? But, okay, moving on to part B, right? If your, let's say your exponent or multiplicity in this case is odd, but it's greater than 1, you have what you call an inflection point. So instead of just crossing, so say for example, let's plot this together. So we now have positive leading coefficient. Okay, I'm just gonna abbreviate coefficient as co-f, but that's coefficient. And your zeros are essentially -3, right? X plus 3 and +2, right? And then your degree now is going to be 5, right? And the reason why it's 5 because it's 2 plus 3, right? So degree is the sum of your multiplicity. In that case, because it's an odd function and it's a leading coefficient, you have a template which is y is equal to x cubed, right? And as a result, you're going to have, or you're going to expect that your function is going to start from quadrant 3, right? And then you're going to have somewhere, I mean something on quadrant 1, right? Because it's positive leading coefficient and it's an odd degree. Okay, so we have that written down. Now, how do you draw your graph, right? So when you're drawing your graph, you're going to have -3 and 2, right? Again, we mentioned because it's starting at quadrant 3, that means you're supposed to have your function starting from the bottom, right? So you're starting here and drawing up. So because at -3, you see that it's 3, right? It's an odd multiplicity, however, it's greater than 1. That means you're going to have what you call an inflection point. So an inflection point is also crossing, right? But it's a little bit flatter because you have a change in, there we go. Let me just, okay, there we go. So this is flatter as opposed to just crossing because you have a change from concave to convex. Basically, that's what it is. So it's like this right here. So you have a change in your concave to convex, and then this is a little bit flatter, right? So that's what happens at -3. But if you have, let's say, at 2, right? If you're looking at x minus 2 and this is 2, you're just going to bounce, right? And how do you know it's not going this way, right? Going down? Well, if your function is odd, that means you're going to finish at quadrant 1. So that means it has to be on top of your x-axis, right? Or above your x-axis. So you're going to bounce here. Okay, so see that bounce? So it only touches your x is equal to 2 and it doesn't cross that because it's an even multiplicity. Okay, so for even multiplicity, right? For example, if it's greater than 2, what happens to your bounds is it just becomes flatter, right? The greater the number, it just becomes flatter. So for example, this is when multiplicity is 2, right? Versus when multiplicity is 4, right? It just becomes flatter. So this is 4. So when you're graphing, it's just really your intuition that you need to make it flatter. Okay. So I think I've covered everything that you need to know for polynomial functions. And yeah, hopefully this is making sense so far. If you do have any questions, please let me know. Okay, cool. So let's move on to question C. Okay, we can see that this is a rational function, right? So if it's a rational function, that means you're going to have a numerator and a denominator, right? So respectively, you have x minus 1. So if it's a rational function, you need to determine whether it has asymptotes, right? Because we know that rational functions have asymptotes. So we can start with vertical asymptote. So for vertical asymptote, you can really assess that in your denominator. So the whole point of a vertical asymptote is your function does not exist there because you have a break there, right? So at x minus 1, which is x is equal to 1, that's your vertical asymptote. Okay, we do have more space at the bottom. So vertical asymptote is x is equal to 1, right? And how do I know it's x is equal to 1? Well, if it's in your denominator, that's going to be your vertical asymptote. And the reason for that is because if you have, let's say, -2 over infinity, right? How do I know this is approaching infinity? Because your vertical asymptote, you don't have your function existing, right? So x is equal to 1, right? And what about your horizontal asymptote? So horizontal asymptote, you're now looking at y, right? But for y, right, you first have to figure out the degree of your numerator versus the degree of your denominator. So horizontal asymptote, again, you have to assess whether your degree of your numerator is less than, equal, or greater than the degree of your denominator. Okay, so here's the following conditions, right, for horizontal asymptotes. If the degree of your, so DEG means degree, if the degree of your numerator is less than the degree of your denominator, so DEN is denominator, that means your horizontal asymptote is 0. Does that make sense? So you don't really have, so in this case, your horizontal asymptote would be 0, right? But, so there's a difference between 0 versus none, by the way. If you say horizontal asymptote is none, that's completely wrong. So you need to make sure if the degree of your numerator is less than the degree of your denominator, it's 0 and not none. Now, moving on to the degree of your numerator, which is greater than the degree of your denominator, and it's only by 1. Okay, so why are we emphasizing that it's only by 1? Well, if it's by 1, that means you're going to assess whether you have a slant asymptote as opposed to horizontal asymptote. So you call this slant or oblique, depending on, again, your teacher, which they prefer, he or she prefers rather. So it's slant or oblique asymptote. So that's what you look for. But in this case, degree of the numerator greater than the degree of your denominator, horizontal asymptote is none. Even though if it's greater than 1, and even though it's just by 1, if your degree of your numerator is greater than the degree of your denominator, your horizontal asymptote is none, not 0. And if it's equal, right? So degree of your numerator is equal to the degree of your denominator, which we're going to look at for the next question, which we can see here at the bottom. If you guys can see this, you can see that the degree of your numerator is 1, the degree of your denominator is 1, and they're equal to one another. You need to look at your end behavior. So in that case, you would have to divide your numerator and your denominator with the highest power of x, right? I'm gonna go over that in a bit, so this is gonna all make sense afterwards. So equal to numerator and denominator, therefore um, there should be a horizontal asymptote. And the horizontal asymptote is basically the ratio of A and C, right? So A is 5, 2 is your C, because it's AX minus B plus CX plus D, right? That's one of your rational functions. Okay, so we can actually say that this is y is equal to 0, and we can move on. So now we have vertical asymptote, horizontal asymptote, and we also have to find our intercepts, right? Because we have x-intercepts and y-intercepts, right? So maybe we can look at our x-intercepts. So for x-intercept, the reason why it's actually none for this particular function is because when you plug 0 right here, so say for example your y, when this is 0, and then you have equal to negative 2 over x minus 1, when you cross multiply 0 times x minus 1, you're going to get 0, right? 0 is equal to negative 2. Therefore, you don't really have any x-intercepts, right? So this is very similar to when you're saying your x-intercept is none versus x-intercept is equal to 0. So you have to be careful with these terminologies. However, for y-intercept, right, how do you find the y-intercept? Well, you just have to plug in x is equal to 0, right? So you have y-intercept, and then this is going to be negative 2 over 0 minus 1, right? So when you find your y-intercept, you're going to see that this is equal to 2. Does that make sense? So if you know that your y-intercept is equal to 2, when you plug in 2, you're going to have a y-intercept here. So this is 2. Vertical asymptote is that x is equal to 1. Okay. That's supposed to hit 1. Okay, you know, you get what I mean, right? There we go. Yeah, this is 1. And then you're going to see that y is equal to 0. Let's maybe label this. So 0 is on your x-axis, right? Here. And then, yeah, that's it. So all you have to really graph is basically have something like this. So you need to pass your y-intercept, and this function is approaching 1, right, from the left side, and then basically you have something like this. Okay, so that's how you draw this function, and hopefully that was pretty straightforward. Yeah, we're gonna do a lot of situations for, or I guess a lot of concepts relating to rational functions, because I know a lot of students just struggle with graphing in general, so that's why I'm starting graphing for advanced functions, and then we'll move on to applications. Okay, so interestingly, there's another rational function here. So we have in the form ax minus b over cx plus d, right? So remember what I said about the horizontal asymptotes? So horizontal asymptotes, right now, you have the same degree, right? So first of all, how do you know it's the same degree?